velocity, but they didn't give us the equation for the acceleration, so let's do that quick. What is the derivative of 160? 0, and so it'd be just negative 32, which is how fast it's going, so that, or how fast it's accelerating. So that is feet per second squared. So when does the rock hit the ground? How do we find that out? No idea? So if you take the original equation, which is the height, and set that equal to 0, that'll tell you when it's on the ground. This one we can do just without a calculator. So if you take negative 16 out, we're left with t squared, what, minus 10t? Or I guess we could take out 16t even. So it'd be 0 equals negative 16t, which was taken out, and then t minus 10. And then if you set both of those equal to 0, the first one t equals 0, which makes sense because that was the starting point, and the second one t equals 10. So 10 seconds is when it hits the ground the second time. This type of problem is a problem they absolutely love to do for free response.
That's good because it's like physics.
Yeah, and it really makes sense, doesn't it, with like your first derivative and your second derivative? In physics, do they ever talk about derivatives?
Not so much like that. Like, I know because this explains more.
Okay.
Because obviously distance divided by time, stuff like that.
Right. Now, I really hate the fact, and this is just something that is just a fact of, sadly, of calculus, is that I hate that they call it S of t for the first function because it looks like a 5, and I hate that. But that's pretty standard across like all curriculums, how you're going to learn it. So the distance, the height, whatever it is, the first function is usually S of t. The next one's V of t, and then usually A of t for acceleration. All right. So find the displacement of the particle during the first 2 seconds. All right, so displacement just means how far it moves. So we need to go from, we can just plug in 2 into the original equation. And we need to subtract where it started. So for A, I'm going to plug in 2 first. Four minus 6, negative 2 plus 3 is, did you get 1 for that? No. 4 minus 6 minus 8. My goodness. Which is negative 4 plus 3, you get negative 1. And then we got to do 0 where it started. Which is 3. So it went from 3 to negative 1, which means it moved negative 4 meters. And this is like on a number line, so it's basically saying that it just is moving left and right. And it moved negative 4 meters, so left 4 meters. B, average velocity of the particle during the first 4 seconds. So for that, we're going to figure out first the velocity function. So V of t equals, go ahead.
2t minus 4.
Correct. Okay, so that's v of t, and then we're going to do basically the, like, v of 4 minus v of 0 divided by 4 minus 0, just as an average. So if I plugged 4 in, I would get 8 minus 4, which is 4. And if I plugged in 0, I'd also get I'd get negative 4, right? Bottom is 4. So that is 8 divided by 4, or 2. Ooh, we did this one wrong. Because average velocity is just how it's changing the original, not how the velocity, because how the velocity is changing, what we just found would be the average acceleration. Okay, so let me change this. Do you need whiteout?
I'll just switch that.
So this is really just s of 4 and s of 0. 16 minus 16 plus 3, and then minus 3 is 0. So the average velocity is 0 meters per second. And then C says, find the instantaneous velocity of the particle when it's at t equals 4. So what do we do for that one? How do you find instantaneous velocity?
Would that be like?
Need some help?
Is that like the f of like 4 plus? Or like?
No, so that, you mean like what we were originally gonna do here? No. So it would just be plugging it into the velocity equation. Yep. Okay, how do I find the acceleration?